So, the thing about exponents is you have to be able to read the notation accurately to understand what's going on. Exponents, like this, the big number at the bottom is called the base. It's the number that's being multiplied by itself some number of times. That number of times is found by the exponent. So, like a to the power of b would mean that we have a times itself, however many times this number is. So, like if it was a to the fifth, then it would be 1, 2, 3, 4, 5. If you really understand that, then everything about exponents will work out pretty easy for you. So let me show you. People always get mixed up with the difference between these two. Okay, this is a squared times a to the third, and it's a to the fifth. The reason why is because a to the squared is 2 a's multiplying, and we're multiplying that by a to the third, which is 3 more a's multiplying, so that's a total of 1, 2, 3, 4, 5 a's. The reason it's a to the fifth isn't because of the rule that you add them. That's just a consequence of the nature of exponents. Here, the base is actually a squared, and we have 3 of those bases multiplying. So we have a squared times a squared times a squared. So there's 2 of each of those. There's 3 groups of 2 all multiplying. That's a to the 6th. Alright, I know we're moving quickly here, but here. This is different. This is a squared plus a to the a cubed. And it turns out that these are not like terms. This is 2 a's multiplying, and it's adding with 3 a's multiplying. And when you look at the order of operations, you'll see that you have to take care of any exponents before you can do addition. So since we can't multiply a times itself, since we don't know what a is, this is the simplest way that we can write it. And so there's nothing more to be done there. However, here, this is 1a cubed plus another a cubed. That's 2a cubed. That gets confusing to people. So if I have one box and I have another box that's the same, isn't that 2 boxes? And it doesn't matter what the box is. It could be anything. It could be a cubes. See? That's why you have 2. And here, we have 1 of something, and we're adding 3 more of the same exact thing. The thing is, they're exactly the same things, so that's 4 of them. Okay? This is a common problem on SAT, at least it used to be. 4 to the 5th plus 4 to the 5th plus 4 to the 5th plus 4 to the 5th. Well, that's 4 to the 5ths. And addition is repeated, or sorry, multiplication is repeated addition. And so here, now we're multiplying. That's 1 4, and 5 more, that's 4 to the 6th. Alright, moving on. Let's say that we've got 2 to the 3rd times 2 to the 8th. That would be 3 2's and 8 2's, so I'd make 11 total. However, here, this is 8 groups of 2 cubed. So that would make a total of 24 2's. The thing is with exponents, unless you're otherwise directed, you don't normally write out the number. With something like 3 squared, I mean, that's really easy. That's 9. In fact, this is easier to write than 3 squared, so maybe you would. But you probably wouldn't write out whatever number that is. You would just leave it 3 to the power of 21. Now, last thing we're going to talk about here. The commutative property of multiplication says that you can change the order. If you look at this entire number here, I don't know what this whole number equals. It would be a gigantic number, but I have 8 5's all multiplying because I have 5 of them here and 3 there, and I also have 10 4's multiplying. So that's what you would do. Hope this video helps.